In this video, we're going to cover the idea of dilutions and how to calculate concentrations after a solution is diluted. So dilutions are very common to use in chemistry because we'll usually start with what's called a stock solution when we're creating a mixture of something. We'll start with a solution that's a stock solution, and this is something that has a high concentration. And what we want to do is often we do this because it's easier to transport solutions when they're highly concentrated. And then when we get them to wherever they need to go, because we can fit more of what we care about, the solute that's dissolved in our solution, once it arrives at its destination, then we can dilute it by adding water to it to get it to whatever concentration we would like. So this is often the case. We take a stock solution, add water, or to be more general, add solvent, but in this case we're thinking about aqueous solutions, and we get a diluted solution with a lower concentration. Let me just move this out of the way. Okay, and so this figure from the textbook I think illustrates this quite well, and that's why I put it on here. So our stock solution is represented by this first solution here. So this is a solution that has copper in it that gives it a blue color, so that's why the water looks blue. And so that's represented by these ions here in this circle here. So what we usually do is take a small amount of our stock solution. In this case, we use a 25 milliliter pipette that's depicted here. And then we transfer that into a fresh flask. And so this is the stock solution here, and then I'm going to use a new color. Let's use green. And then this is our new flask. So all three flasks over here, 1, 2, 3, these are just like a time lapse of what's happening as we dilute the solution. So we take our 25 milliliters, put it into the new flask, that's represented here, and this is our stock solution. And it has whatever concentration the stock solution started at. So for example, if I believe in this figure it mentions that this is a 0.1 molar solution, meaning it's 0.1 moles of copper for every 1 liter of solution. So then once we transfer it to the new flask, it still has that same concentration, 0.1 molar solution. And then what we do is we add water to it. And so that's what's being represented by this hand here. We add water to this flask until it reaches the line here, and so that dilutes it. Right? So the amount of copper stays the same, but we add a lot more solvent. And so the concentration decreases. So it will no longer be 0.1 molar because we added a bunch of solvent. So the amount of solute stayed the same, but we have a lot more solvent, and so the denominator in our fraction that we use to calculate molarity has changed. And so you can see this depicted in this second picture here, that there's a lot fewer copper atoms, or ions in this case, for a given amount of solution. And so that's because we added a bunch of solvent to it. Let's go into how we actually calculate this. And that's sort of depicted in the bottom part of this figure, but I'm going to slide down and just do it myself below. If we think about our stock solution, so let's use a specific example here. Let's use that 0.1 molar that I had earlier. Maybe in this of copper ions, copper 2 specifically here. And let's say that we take out 25 milliliters of that stock solution. If I then add that to a 250 milliliter flask and fill it all the way up with water, what is the concentration at the end of this? So we know it's lower, but we want to be able to quantify that. So let's walk through how to do this, and this will be a specific example, but I think illustrates the general idea here. So the way to look at this is to think, as always, go back to moles. How many moles of copper is represented by this? So if we remember the definition of molarity and what we talked about in the previous video, if we multiply these together, 25 milliliters, convert it to liters, times our 0.10 moles of copper per liter of solution. Our milliliters are going to cancel, our liters are going to cancel, and we're going to get moles here. And this tells us that we'll get, pull up the calculator, make sure I don't mess this up. We will have 25 divided by 1,000 times 0.1, which gives us 0.0025 moles of copper. Now, when we add that to the second flask, the only thing we add after that is water. So this will stay the same. So the number of moles stays the same. What's going to change is our volume of solution. So to find we have our new volume of solution. We're told that it's a 250 milliliter flask, and we filled it all the way up. So once that's done, we know that, and so we can use our moles that stayed the same, 0.0025 moles of copper, and divide it by our new volume, 250 milliliters, or if we convert that, that's 0.250 liters. You can double check me on that if you do that conversion from milliliters to liters, that's what you'll get. So if we go ahead and do this calculation, pull up the calculator again, have that same answer from there, divided by 0.25, we get 0.010 to keep the same number of sig figs, molar copper. So by transferring 25 milliliters of this and diluting it to a total volume of 250 milliliters, we decreased the concentration by 10 times. It went from 0.1 molar to 0.01 molar. And that's not a coincidence. I picked these numbers so that you would get exactly 10 times less concentration. So how does this work in general? How will we generalize this into an equation? Well, the basic idea is that your number of moles stays constant because you're just adding solvent in the process. So how do we find the number of moles? We take our concentration, initial, or we could call this number 1. This is the way this is often written. So I'll just say 1. What we started with, this M represents our concentration in molarity. It could be any concentration units, but we'll stick to molarity. Multiplied by the volume. And this just represents the number of moles. So that's where this is coming from. And that's going to be equal to the number of moles in the diluted solution. And how do we find the number of moles in the diluted solution? Well, it'll just be whatever the new concentration is times the new volume. And so this is a very versatile equation. You can use it to find, like we did, the concentration of a new solution if you know the new volume. Basically, what you need is 3 out of these 4 variables here. As long as you know 3 out of the 4, you can find the 4th one. You just have to rearrange the equation to get that. And why does this equation work? It all comes back to this idea of your number of moles is constant when you're doing a dilution. Because when you dilute, you're just adding solvent. You're not adding any extra, in this case copper, or whatever it is that's the solute that's dissolved in your solution. And so we'll practice this in class. You'll also get practice with it on your homework of using this idea of dilution and finding, the concentrations of diluted solutions.